This conference will now be recorded.
Hi guys, good evening. Yes, can you hear me? Hello.
Yes, sir. Good morning.
Yeah, yeah. Thank you. So we'll start session. Yes. Today's topic is typecasting. Typecasting. Yes. What is typecasting here? Let us say about typecasting. What is typecasting? Typecasting, it's a conversion of data from one type to another type. Typecasting, yes, it is a conversion. Yes, conversion of data from one type to another type. Yes, it's a conversion of data. Typecasting, it's a conversion of data. It's a conversion of data from one type to another type. Let's see exactly what is this concept. So exactly what is this? Okay, it's a conversion of data from one type to another type. Yes, it's a conversion of data. Typecasting, it's a conversion of data from one type to another type. It's a conversion of data from one type to another type. Okay. Yes, here data types. Previously discussed about data types. Yes, in data types, yes, we have discussed two types, like primitive and non-primitive. Yes, here also same. In typecasting also, there are two types. Primitive casting, yes, primitive, yes, primitive, yes, primitive casting. Next, second one, non-primitive casting, primitive and non-primitive. So primitive, non-primitive. So primitive and non-primitive here. So primitive casting and non-primitive casting. So primitive and non-primitive here. Yes, in typecasting, they say primitive casting, and non-primitive casting. Okay, typecasting. There are two types. Primitive casting means basic data types. Yes, this thing. Yes, data types, basic data types are discussed. Okay, next, non-primitive. Yes, it's a whoops concept. Non-primitive. Yes, primitive casting. Let us see what primitive casting. Non-primitive casting we'll discuss in whoops. Okay, non-primitive casting, it's a part of non-primitive. It's a part of whoops. Now, let us say about primitive casting. What is primitive casting? Yes, at this stage about primitive casting, because we discussed about the primitive data types. We have discussed about the primitive data types. Primitive data types already we have discussed it. So we'll be discussing about primitive casting. Non-primitive casting, it's a whoops concept. In whoops, we'll discuss that. Okay. Yes, primitive casting. Yes, primitive casting. Yes, conversion from one type to another type. Like integer to float to integer. Integer to float conversion, float to integer. Next, byte to short conversion, short to int conversion, integer to short, like this. Like different conversions here, different conversions. Okay, let us see one by one here. Suppose, for example, byte a
Sir,
equal to,
sir, I have a question.
yeah, tell me.
So non-primitive data type we also called user-defined data type or its
Yeah,
other
user
data.
defined. Yeah, user defined data. Non-primitive or user defined. Okay, classes. All the classes comes on non-primitive. Non-primitive or user defined. Okay, primitive means system defined. Non-primitive means user defined. User defined. All the classes. Okay, I think clear, right?
Right. Thank you, sir.
All the classes comes on non-primitive. All the classes non-primitive is user defined. Classes are user defined. Classes are user defined. Like int, byte, char, they are predefined. Okay. So primitive casting, byte b equal to 10, byte b equal 10. Suppose short yes equal to b. Yes, this statement. Yes, is it valid or not? Yes, let us see. Yeah, this statement, is it valid? Byte b equal to 10. What is size of byte variable here? Byte b. What is size of variable b? What is size of b? Only 1 byte. What is size of byte? Size of byte is 1 byte. Size of byte is 1. So what is size of b? Only 1 byte. So 1 byte of data trying to store into short type of variable, right? Short. What is size of short here? 2 bytes. Size of byte is 1 byte. Size of short is 2 bytes. So size of b is 1 byte. Size of s is 2 bytes. Size of b is 1 byte. Size of B is 1 byte. Size of short is S is 2 bytes. That means 2 bytes of data. Yes, sorry, 1 byte of data. Size of B is 1 byte. That 1 byte of data, 1 byte of data trying to store in 2 bytes of location. So 1 byte of data trying to store in 2 bytes of location. Yes, why not valid? Valid. 1 byte can be stored in 2 bytes of location. See, it's a 1 byte of data. That 1 byte of data can be stored into 2 bytes of location. It's a valid. It's valid. Okay. Now let us see this. Yes. Main method. In main method, byte b equal to 10. Short s equal to b. Okay. Byte b equal to 10. Short s equal to b. So it's valid. No error message. No error message. System dot out dot println. Yes. Displaying yes. Short yes. Displaying short yes. Okay. Displaying short yes. Byte b equal to 10. Short s equal to b. So b value assigned to variable yes, right? Okay, it's valid. Now run it. Yes, fine. So what is happening here? Byte type of data converting to short type, automatically converting. We are not doing anything here. Automatically converting. This type of conversion is called implicit casting. Yes. In this casting, in primitive casting, there are two types again here. First one, implicit casting. First one, implicit casting. First one, implicit casting. First one, implicit casting. Second one, explicit casting. There is implicit and explicit. Okay. So implicit and explicit. Implicit and explicit here. Implicit casting and explicit casting. Implicit casting and explicit casting. Implicitly means internally, automatically. Okay, explicit limits you have to convert it here. As a Java developer, we should convert it. Okay, implicit limits automatically converting here. The explicit limits you have to convert it. So first, let us see implicit casting. So what is implicit casting? Yes, implicit casting. See, implicit casting is like this. Implicit casting. Implicit casting. See, implicit casting. Yes, implicit casting. This byte b equal to 10, short s equal to b, right? So b variable assigned yes. Okay. Now what is happening here? Byte b equal to 10, short s equal to b, right? Byte b equal to 10, byte b equal to 10, short s equal to b. So b, 1 byte of memory, 1 byte of memory storing 2 bytes of location. Yes, valid, valid. So what is happening here? So byte 1 byte of data, yes, stored in 2 bytes of location is small type to big type. Okay, so byte type of data convert into short type. See, b type is byte. That byte type of data storing the short type of variable, right? So byte to short conversion, byte to short conversion, it's valid implicitly, automatically. Small type to big type, no issue here. 1 byte of data can be stored in 2 bytes of location. It's a valid. So 1 byte to 2 bytes valid. So this is the implicit casting. Okay. Okay, right. Next, one more thing. Int. Suppose int I equal to yes, for example. This is also valid. So what is size of x? 2 bytes. What is size of I? 4 bytes. So 2 bytes of data stored into 4 bytes of location. It's a valid. Yes, similarly here long L is equal to I. Long L equal to I here. So integer converting long, right? So here byte to short, short integer long. So small type to big type. So what is happening? Implicitly converting, automatically converting, right? Automatically converting. So this type of casting is implicit casting. This type of casting is a implicit casting. This type of casting is called implicit casting. So what is implicit casting? Yes, it's a conversion of data. Yes, it is a conversion of. Yes, it's a conversion of data from small type to big type. Small type to big type. Small type to big type. It's a conversion of data from small type to big type. Small type to big type. So implicit casting. Implicit casting, it's a conversion of data from small type to big type. So this implicit casting. Okay. Yes. Next, here, see implicit casting. Yes, implicit casting. Implicit casting is available. Is available. Available. Available for first one, small type to big type. Small type to big. First one is small type to big type. So this is small type to big type, right? Next, float. Float f is equal to l. Yes. So this also valid. Yes, long type converting to float type. See, long convert into floats, not a lot, even integer also can be converted into floats. So integer to floats. Integer to float conversion, this is. See, long to float conversion. This long to float conversion. Next I means integer to float conversion. Yes, next. Yes means short. Short type to float conversion. Value short to float conversion. Yes, byte to conversion. Byte to float. That means yes, all this integer data. Integer data, yes, can be converted into real number type. Integer to real type. Yes, simplicity available. Automatic. Even long type also you can convert here. Long to float, that conversion available. See what is size of long? 8 bytes. What is size of float? Only 4 bytes. Even 4 bytes, that type of casting is available. Long can be converted into float type. See, size of long is 8 bytes. Okay, size of float is 4 bytes. Even 8 bytes here, long type of data can be converted into float type here. Okay, yes. Now I'll show that. So what happens here? Yes, I'll show that. 1 second. See, byte b equal 10. Now float f is equal to b. So what's the value of f here? What's the value of f? It's now 10.0. So b is 10. Once assigned f, that value becomes 10.0. That value becomes not 10.0. It's a 10.0. 10.0. Suppose short s equal 10. Short b equal 10. So short converting float type. Same 10.0. 10.0. Okay, short to floats. Short to floats. Next integer to floats. Integer to floats. Yes, 10.0. 10.0. Yes, even long to floats. Long also can be converted to float type here. So long floats. Long to floats. Yes, converted like this. Okay. So implicit casting is available for small type to big type. Next, yes, integer, integer,
Sir,
real number,
sir,
integer to real number.
if the value of long, if the value of long is more than 4 byte, then the float will convert
Yeah,
it
that
into.
is, yeah, yeah. That case, if suppose long size is more than the floats, that case fails. Compile compiles, but runtime fails. But rare that the scenario. That scenario better take double. In that case, take double. Better take double. Okay, if long type as a Java developer is expecting very big number in long, very big number, that case better go for double. Double type, take double type. As a developer, you have to decide it. As a Java developer, you have to decide. In place of float, better you take double. Better you take double. Okay, right? Better take double here. Okay. In place of yes, float better you take double. That's it here. Right, okay. Yes. So this implicit casting, small type to big type, integer to real number type. It's available. Okay, right? Yes, suppose if you want reverse. Okay, big type to small type, real number to integer. Then way is what explicit casting. So next explicit casting here. Explicit casting. So next one is explicit casting here. Yes, sir. One second. Before that, we have one more term. Here. See, so implicit casting available from small to big type, that's okay. Integer to real number, that's okay, fine. Now here see this byte type of data can be assigned to short type. Okay, the short type of data can be assigned to int type. That int type of data can be assigned long type here, long type. See byte assigned to short assigned to int assigned long can be assigned to yes, float. Float can be assigned to double. Okay, small type to big type called as type promotion. It's a type promotion. Okay, see byte is promoting to short to promoting to int promoting to long promoting to double, float to promoting double. That's it. It's a type promotion, type promotion like this. Okay, so byte can convert in short to int to long to float to double. Okay, next suppose character, for example character. Let us take char type here. Let us take char. Let us take char type here. Char ch is equal to suppose character a. Character a. This is try to ascend byte b equal to ch, not valid. Char to byte conversion is not available. Okay, next take short. This also not available. Okay, next integer. Yes, integer. Yes. Character can be converted integer type. Okay. Now let us see this. What is ch value? What is b value here? ch value, next int I, suppose int I, yes, next ch value is a, so what's the value of I? Yes, let us display I value here, I value. What happens here? Ch equal to a, so ch value here, right? It's a output here, output is a. Now ch a converted integer, once converted ASCII value. It will take ASCII LFA and ascend I. What is the ASCII LFA? 65. That's 65 ascend I. So what's the value of I here? Value of I is what? 65. Output is 65. ch value is a. Yes, that integer I value is 65. ASCII value. Getting ASCII value. Run as series a and 65. So char to integer converted. That ASCII value getting. That's it here. Okay. So character. So char can we convert integer here. So this is char promoting the integer. Okay. From that, this. That's it. So this is data types. Type promotion is like this. Type promotion. Implicit casting. Small to big. Small to big. Implicit casting is like this. Implicit casting. Okay. Next, second one, explicit casting. Explicit casting. Yes, explicit casting. Yes. So reverse. Yes, it is a conversion of data. It's a conversion. Yes, conversion of data from, yes, big type to small type, big type to small type, small type, big type to small type. Okay. Yes. For example, here, see. For example, here, yes, short s equal to, suppose 10 bytes, b equal to, yes. See this, it's error message. Why this error message? What is size of short variable? 2 bytes. What is size of byte? 1 byte. 1 byte here. That means 2 bytes of location. 2 bytes of data. We are trying to store 1 byte of location. Yes. How it is possible? Not possible, right? 2 bytes of data. We are trying to store into byte location. 1 byte location. Not valid. Support directly 10 bits valid. No problem. No issue here. Okay. See here. So byte b equal 10. This is valid. B equal 10 is valid. Reason size of byte is, yes, 1 byte here. Byte variable type is, byte type is 1 byte. Size is 1 byte here. Byte type of variable. Size is 1 byte. 1 byte max value is 127. It can take up to 127. 127. No issue. 128. Yes, is the error message. Okay. It's error. 128 error message. 10. No problem. No issue. In place of 10, I'm using yes. Yes. 10 ascend yes. Okay. Now yes ascend b. What happens here? Compiler don't have about values. Yes can is what some value. Runtime getting value. Compiler don't think about value. Compiler think about variable here. Compiler never think about value 10 here. Suppose if you assign 10 here, then compiler now think about 10 here. Now compiler thinking about 10. Now this case compiler thinking about value 10 by directly as 10 assigned. So thinking about value. Thinking about this one, right? Suppose if says yes. Now compiler thinking about yes, not 10 here. Compiler don't know what is the value of s. Yes, runtime getting value of s, correct? Compiler don't know value of s. Compiler always thinks about variable here. What is variable? Yes. Size of s is what here? 2 bytes. So 2 bytes of data we are trying to store 1 byte of location. Not valid. Not valid. Suppose as a Java programmer, still if you want to convert here, because s value 10 is there, that 10 can be assigned to b. Still if you want to convert, just you can convert like this, byte. Like this, byte. Yes, convert it. Okay. So byte. So taking the 10 assigned b here. Okay. So like this you can convert. So the big type to small type conversion. Print b value here. Yes, run as. So what's the value b? Getting 10. Okay. Yes, one more example. Suppose short yes. Okay, one more example. Integer. Suppose integer I is equal to 1000. 1000. These are sent to short x equal to I. Okay. Say this. Int I equal 1000. Okay. Short x equal I. So this is not valid. This is not valid here. So not valid. 4 bytes of data we are trying to send 2 bytes of location. Not valid. So directly 1000, no problem. No problem, because Short can take value up to 32,767. 2 bytes of location can take value up to 32,767. Suppose when you assign 1000 directly, compiler thinking about value. Compiler thinking here about value. Suppose if it is I, compiler are thinking about variable here. Now compiler thinking about variable I. So what is size of I? 4 bytes. 4 bytes cannot be assigned to 2 bytes of location. Still, if you want to convert as a developer, you can convert short. Make it short. Make it short. Okay. Now system dot out dot println display x value. Display x value getting 1000. X value 1000. X value 1000. So this is explicit casting. Okay. Explicitly casting is like this. Okay. So converting from big type to small type. Converting, it's a conversion of data from big type to small type. Okay. Yes. Next. Suppose yes, simplicity casting small to big type, that's okay fine. Integer to real number, okay fine. Now real number to integer. Yes, next requirement is real number to integer. Yes, real number. Yes, real number to yes, real number. Real number to integer type here. Okay. Implicity not available. Real number to integer. Yes, explicitly you have to convert it here. Real number. Now let us take it. Suppose real number. Let us take real numbers. Suppose for example here double. Okay, for example, one second, float f equal to 10.5. Here this is error message. This is error message. Reason, Java real numbers are by default double type. See, integer number is by default int type. Integer numbers are int type, not byte shorts. See in byte, next in shorts, next in int, in long, we can store integer type of data. Integer type of data we can store in any of these things. Okay. By default, integer type is int type, not byte short and long here. Integer type. By default, integer numbers. By default, integer numbers are int type. So integer numbers are int type. Real numbers are double type. By default, real numbers are double type. Now it's a double. 10 point is double. Not double type of data stored into float location. Float type of location. So 10.5 it's a double means what is size of double? 8 bytes. Now 8 bytes of data we are trying to store into 4 bytes of location, not valid. Now we should go for casting. So how to cast it? Float. Before this use float, casting simply. You can cast it like this. You can cast it like this. Okay. Now double converts into float type. Double converts into float type assign f, or else simply at the end f we can use. Uppercase f or lowercase f, anyone is valid. No problem, no issue here. It is uppercase f or lowercase f. F means float. Explicitly converting to float type, then assign f. That's it. Okay. Now float. Real number to integer. Now int I is equal to f. Int I equal to f. Okay. Not valid. Error message. Float cannot be converted integer. Float type of data. Real number you cannot convert directly here. Yes, you have to explicitly have to cast it here. So there is no implicit casting. It won't convert directly here. You have to do that. Implicit casting is not available. Internal not available. You have to cast it. How to cast it here? Int. So before this, place int keyword. That's it here. Int. Now system dot out dot println. System dot out dot println of I. Display value of I. Now what's the value of I here? Now what happens here? Int I equal to int of f, right? What happens here now? Int typecasting means it will read integer part of f. It will read only integer part of f. Integer part of f means 10 percentage. That's it here. Means terminating dot 5 and 10 percentage. So value of 5 is what? 10 here. So integer part of f. Here conversion. Just take integer part of f. Integer part of f is what? 10 percentage here. So what's the value of 5? It's 10 here. So output is 10 here. Output is 10. Output is 10. That's it here. Output 10, I guess. So this is float to integer conversion. Float to integer conversion. Float to integer conversion. Okay, like this. Fine. So this is we are converting from float to integer conversion. So typecasting explicitly. Okay. Yes. Now here. So here big number to big type to small type. Explicit casting. Okay. Yes. Yes. Required for big type to small type. Explicit casting is required for big type to small type. Second one, yes, real number to integer type. These cases required here. These cases require explicit casting. See, implicit casting. Implicit casting is for the small type to big type, integer to real number. So automatically happens. You need not to convert here. Automatically converting this is these two cases automatically. But when come to these two cases, you have to convert. As a developer, you should convert it here. Explicit casting. So explicit casting is required. Explicit casting required for big type to small type and real number to integer type. That's it here. Okay. Yes. Yes. In this explicit casting, some issues facing in real time. Yes, in real time production jobs, maybe some projects. Okay, some issue. Yes, in one of our projects, we faced one issue in typecasting. I'll tell you that issue here. Okay. Yes. Suppose font yes is equal to 100. Okay. Byte D is equal to yes. Let us take into Eclipse here. Yes. See, short yes equal to 100. Byte B equal to yes. Okay. For this, we are using typecasting, into typecasting. Sorry, byte typecasting. Byte typecasting. Okay. Now, system dot out dot print of B displaying B value. So, what is output here? Getting 100. Fine. Suppose this value is short wave increased to 127. It's 127. 127. 127 correct value. Now let us make it 130. Can I get 130 here? Yes. Short yes value 130. Now 130 we are assigned to byte B. What happens? Yes, B cannot take 130. Yes, yes contains what? Yes contains what? 130. That 130 assigned to B, right? What happens here? At compile time, compiler compiles because as compiler following syntax, compiler don't have a runtime value. The runtime may be getting 130 or 120 or 100. Compiler don't have, but it's compiler checking for syntax. As per syntax is correct. Okay. As per compiler it's correct. Okay. As per compiler it's correct. Okay. As per compiler it's correct. Okay. Suppose if you run this program, what happens here? See, S value 130, value of S is 130. 130 assigned to be no. How it cannot. So maximum value, yes, that can be stored into B is only 127. 127. More than 127 cannot. So what happens here? Simply fails. Simply fails. Now let us run this. What is output of this? Minus 126 got it. Minus 126 got it. Why? What's the reason? Yes, it's a data overflow. So whenever data overflow comes, more than 127 is data overflow. So whenever data overflow comes, then cycle goes to negative side. Cycle of operation. Past is 127, negative side is 128. It go to back cycle. Yes, I'll explain about that cycle here. Let us see that. So how that processor working here? In data overflow, how processor is working here? Now 130. So 130. So value 130. 130. So that 130 convert into byte. So byte rate from 130, yes, it will subtract 127 getting difference. What's the difference of this? What is the difference of this? It's 3. So it's the difference is 3. From this 3, it will take 1. So result is 2. After getting this here, next what happens here? Yes, 127 max value. Max is 127. Okay. To this 127 plus 3 minus 1. This one add to this. Okay. Applying minus on this means it will take to negative side. Cycle go to negative side. Okay. See one maximal 127. 127 plus 1. That one taken. That one added to 127. Yes, after that plus the balance value 2, right? Add to this. See what happens here. See here maximally 127. So 3 minus 1. So difference is 3. From the difference, it will subtract 1. Processor how it's working is like this. If data overflow, in data overflow, processor working is like this. See 130, 127 difference is 3. 3 minus 1 result is 2 here. So this one, subtracting one, that one added to maximum value, 127 plus 1. Next, it will take to negative sides. Cycle goes to negative sides. Minus 128, minus 127, minus 126, minus 125, minus 124, 123, 122, 121, like this. The cycle, repetition of the cycle here. So minus 127 plus 1. So this one add to 127 will take to negative side here. Next, that balance value 2 add to this. After adding, what is the result of this here? Minus, so minus 128 plus 2. So what is this one? This one is equal to minus 126. That's it. Minus 126. So getting value like this. Okay. So once you run this is here, now getting minus 126. Now
So why
let
did
us
we
make it
subtract to
150.
minus 1?
It's a processor concept. It's a hardware that processor designing is like that. Okay, data overflow. 127 more than 127 it can't take. Then it take to negative side. Means cycler. Yes, it's circular. It's a circular queue, like a circular queue. It will take to negative sides. One after 127 next is minus 128, minus 127, minus 126 like this. It's a cycle. It's like that goes to minus 128. Okay, that one add to 127 takes to minus 128. Okay, that will be taken to 128. It's a cycle. It's a processor concept like that. It's a processor concept like this. Okay. So minus 128 plus 2, it's a minus 126. Its value 126. Now, can you type for this 150? 150. What's the result for 150? Same. Try same operation for 150. Same operation, try for 150. Yes, 150 place of 130, now it's 150. Try for 150. Yes, just 1 minute of time is enough.
Minus 106.
Minus
106.
Yeah, right. Yeah. Base of 130, 150, right? 20 adding. Okay, here, base of 130 now 150. That means plus 20. Plus 20. So minus 126 plus 20, it's a 106. That's it. Or else let us try calculate this one here. What's the difference here? 150 minus 107. So it's a 23, right? It's a 23. It's a 23. 23 minus 1 is equal to, it's a 22, right? It's a 22. 27, 30, 23. Yes, 22. So plus 1, so plus 22, plus 22. So 120 plus 22. 22 is 106. Minus 106. Okay, minus 106. Okay, let us run this. Minus 106. Yes, let us make it 500. Yes, try this 500. Yes, I'll give 2 minutes of time for you. 2 minutes.
Minus 12.
Minus 12. Okay.
Yes, sir.
Yes, others. Yeah, others try it. Yes, no one answering. Yes, just is a mathematics, right? Just calculate mathematics. Just try this mathematics. It's in mathematics. Yes, guys. Yes, many completed BTech engineers. Simple mathematics. Okay, let me try. So this is 500 minus 127. What is this value? Say 373, 330, 373. Right? The difference 373, 80. Oh, yes, 373 minus this is 372 getting 372, right? It's a 372. Okay, 127 plus 1 plus 372. 372. Okay, so this is 372. 372. So what is this value? 372. So it's a 144, 244, I think. So it's a 244. 372, 244. Yes. 244. It's a 244. Yes. Result is what? 240. Answer is 244. But 244 cannot accommodate to byte B. It's a maximum 107. So this is first cycle completed. Result of first cycle is 122 to 244. Even this also not accommodating here. Yes, now second cycle starts. 244 minus 127. So 127. So what's the difference here? Difference is now, yes, difference is 117, 127, 134. Yes, right. 117 difference. 117 minus 1. You say 116. 116. Now minus, yes, 127 plus 1. 128 plus 116. So what is this value? This value is equal to is minus 128 plus 116 is equal to what is this value? It's a minus 12. That's it. Minus 12. Let us take minus 12. Minus 12 got it. That's it. I hope everyone understand. Yes, ma'am, you missing some 10. Okay, minus 12. It's not minus 2. Yes, yes, Timach, you also okay, fine. 12, but minus is missing. Okay, yes. So minus 12, it's not a yes. Yeah, some calculation you miss it 10. It's a minus 12. It's a minus 12. Right?
That I said minus 2.
Not only here. Minus 12. Yeah, you said minus 12. Right. See, not only here, anywhere if data overflow is there, that case it happens like this. Internally, processor converts our data like this. Okay. Now here, suppose situation happens like this, what happens here? Expecting for what? 500 output, but we are getting minus 12. Means unexpected value means bugs. It's a bug. Okay. See, expecting for 500 but getting minus 12 means this kind of typecasting leads to bugs. See, expected casting leads to bugs always. Expected casting leads to bugs. Chance of getting bug means unexpected results. Unexpected is a bug. So this type of typecasting, expected casting always leads to bugs. Then where exactly using here? Constants. Yes, expert casting is recommended only for the constants. Suppose, yes, for example, here, short variable, initially 10 is there. Initially 10, variable, it's a variable. Variable, right? Variable 10. Yes, later, yes, maybe next statement. Suppose byte be somewhere using, yes, in projects, somewhere this type casting using. So between this initial value and this casting, yeah, there are some statements. Maybe many statements in real-time projects. So at the somewhere declared at the beginning here, now this statement somewhere in the project, right? somewhere. So between this and this statement, many number of statements, many other statements. So during these statements here, maybe chance of changing S value. Suppose S value 10, fine, no problem. Next statement maybe changing S value, next changing. By the time of reaching this one here, S value is 127, no problem. Suppose more than 127, it fails. Okay. See, between these statements and this statement, maybe many number of statements in the real-time projects. So by the time of starting from this here, by the time of reaching this one here, S value may be changing. Suppose S value is 127, no problem. Suppose by the time of reaching to the statement, S value is more than 127, simply the statement fails. Not this one. I'm making as final. Final means constant. It's a constant. Okay, so value of S is 10 here. Now S equal to 20. Try to change it. Not accepting. Okay, not accepting it. Okay, now here, as a developer, you know that it's a final means constant. Means its value cannot be changed here. Short S equal 10. So S value 10 means there is no chance of changing 10, right? There is no chance of changing S value. Always 10 is fixed. If it is fixed, we can make it typecasting like this. It's a fixed one here. The 10 is fixed. The final means it's a constant, to declare constant. So once declared final here, its value cannot be changed. Now variable yes, it's a constant. Its value cannot be changed. Cannot be changed. Okay. Then we can use typecast. No problem. No issue for this. Okay. Yes, 10. Yes, as a developer, you know that value. So you can do with typecasting, right? So explicit casting is recommended for constants, not for variables. Okay. Same issue we have faced in one of our projects. So that time we have converted that variable into finally very constant. So we have converted that variable to constant. So once a constant, that value cannot be changed. Yes, maybe in other modules, maybe chance of changing, no chance. Here's a final. If it is final, no chance of changing it. It's a constant. Okay, so no problem, no issue in this case. Okay, so here, yes, explicit casting is recommended for constants, not for variables. Explicit casting is recommended for constants, not for variables. Okay, so about implicit and explicit casting. Okay, same point mentioned document also. Document also very clearly prepared typecasting. So what we discussed till now here. Okay, so everything is there in document here. Document I have mentioned very clearly. Yes, see the documents. Yes, our document is like a spoon feeding, very easy to understand. Okay, yes, very clearly prepared our document. Step by step prepared. Everyone step by step prepared. Yes, casting, typecasting. Yes, typecasting. See, typecasting. Yes, it's a process of converting one data type to another data type. There are two types here, primitive and non-primitive here. Non-primitive means user-defined classes. User-defined. Okay. Yes, here primitive data types casting here. Implicit casting, explicit casting here. Implicit. Yes, it's a conversion of data from small type to big data. It's implicit process. Example, byte b equal to short s equal b. Here, byte type of data converted short. Type promotion value. Data type and its type promotion. Byte to short, short to int, long, float, double like this. Char to int like this. Okay. Next, implicit casting is available for below here. Implicit casting, small size to big size. Yes, integer to real number. Okay. Yes, converting from real number to integer, implicit casting is not applicable. Yet to convert real number to yes integer, we should go for explicit casting here. Explicit casting here. Okay. See, explicit casting, it's a conversion of data from big type to small type. Java developer has to convert explicitly. Now, as a developer, see this. Short a equal to 10 here, byte b equal to invalid. Reason, yes, size of variable a is 2 bytes, which is more than size of variable b 1 byte here. Such kind of scenarios go for explicit casting here. Short a equal to 10, so byte it's a casting. Now it is valid. Okay, same scenario with following. Short a equal to 130 here, byte b equal to a. Here this one leads to bugs. Okay, here value of b is minus 126. Here explicit typecasting is recommended only for constants, not for variables. Constants, not for variables. Okay, right? Yes, next. Here float A equal 10.5 invalid. Reason, in Java real numbers are by default treated as double type. By default double type. So make it like this, it's valid. This when come to default data type here, integer numbers, okay, is a int type, but not short and white here. Int type here, int data type. Integer numbers are int type here. Real numbers are double type. Real numbers are double type. Okay, fine. Now, next one more scenario. Now, question for you guys. Maybe interview question. This is byte b1 equal to 10. Okay. Yes. Byte b2 equal to yes 20. Okay. Next, yes, b3 is equal to b1 plus b2. b1 plus b2. Now tell me, what is data type of b3? There is a question. Interview question. Byte b1 equal 10, byte b2 equal 20, b3 equal b1 plus b2. What's the type of b3 type here? What's the type of b3? Yes, anyone? Can I use same byte?
Yes, sir. It is also byte type.
Also byte type. Okay, let us check it. Suppose this 10, this is 20. 10 plus 20, it's a 30, right? Suppose b1 variable later changing value. b1 value changing. Suppose here maybe changing value. So b1 changing to some 100. Okay, b1 changing to 100 in programming. Okay, because it's a yes live today 10 in live project here, live here today 10. Maybe data reading from different locations, maybe from database or different locations. Today 10, tomorrow maybe 100. Today 10, tomorrow maybe 20, next day 30, next day 40. Suppose maybe after 3 months maybe 100 that value, b1 value. So b2 value is equal to b2 is equal to, suppose this also maybe some 110 value. Okay, so b1 100, b2 110. Fine. Even maximum up to 127. Suppose reach it to 127. This is so b2 also reach to 127. Not more than maximum only 127. So this is 127. This is 127. Reach it to maximum value. So b1 plus b2. What is that value here? What is that? 127 plus 127. It's a 254.
54.
What happened? This result 254. The result variable fails. So what's over here? Better go for short.
Short.
Okay, 1 byte plus 1 byte, 2 bytes is short, right? But compiler will not accept here. Byte plus byte is integer. Compiler will take integer type here. Byte plus byte is integer. See this. Byte plus byte is integer. Yes, let us check it. See this. See this. Yes. Byte plus byte is yes in the sub of byte. Take it as byte type. It's not working. It's not working here. So byte plus byte is not working. It's integer. Byte plus byte is integer always. Byte plus byte is integer always. Okay, byte plus byte is integer here. So take it as integer. It's integer. So compile will not accept. Byte plus byte is integer. No, let us see this. Yes, now here. Yes, byte plus byte. It's a int. Byte plus byte is int. Short plus short. Short plus short is also int. Okay, next int plus int. Int plus int is also int as per compiler, but recommended is long. So go for long type. Don't use int plus int here. As per compiler, int plus int is int working, but in real time fails. Better go for long. Long. You choose long here. So byte plus byte is integer here. Short plus short is integer here. Int plus int is long. Suppose long plus long is long only here. Long plus long is long. There is no alternative. Next level here. Long plus long. Suppose int plus long is there, then result is what? Long type. So big type here. So this is 4 bytes, 8 bytes. Result is 8 bytes. Take into big type here. So small type plus big type, which is taken to big type. Suppose for example integer plus float. What is the result? Can you expect the results? Integer plus result is what here? Integer plus float result is what? Is it integer or float type?
Float type.
It's a float type. See, reason is here. Suppose 10 is there, 10 plus 10.5. What is the result here? It's a 20.5, right? Means real number. So integer plus real number is real number. Okay, right? Yes, integer plus float is float type here. Okay, right? Yes, next. Float plus float. What is the result here? What is the result for this? Float plus
Double.
float is what? Next level is double. Take it as double. It's a double. Double. Suppose float plus double is there. Float plus double. Float plus double. Result is what? Big one. So double type. That's it. This is one more. Okay. So in typecasting, this case, yes, in data types, this kind of things you have to consider. You should know about all the things here. Okay. These all are my practical experience. Okay, you have to consider like this. Okay, fine. Next, one more operation. One more thing in data types here. Suppose int a equal to 10. Okay. Yes. Next, int a equal 10. Suppose x equal to yes a by 2. System dot out dot middle of x. What's the type of x? Tell me.
It is float.
What's the type of x? Integer. Integer. Okay. Yes, a by 2, 10 by 2 is integer. So getting integer value. Fine. Suppose 5, right? Suppose 3 is there. What's 12 x? Yes, it must be float.
Then it will be float.
Hey, see, division operation result is always float, not integer. Don't take integer here. Result of the division is always float. Result of division is always float. Don't take it integer type here. Result of division is always float. Okay, result of division value is always float here. Now, what is the output of this? 10 by 3. What is output of this?
3.33.
2.5.
2.5. 10 by 3. 10 by 3.
3.34.
You say 10 by 3. 3.333 getting right?
3 point
Not
something.
3.0. 3.33 we should get it, but we got 3.0. 3.0 reason. See, not on Java, C, C++, Java, Scala. Integer by integer is result is integer. Of course, in Python, integer by integer will get the float. In Python, no issue. Okay, Python, no issue. Yes, C, C plus Java, integer by integer result is integer only. So what happens actually here? Actual value is 3.33 something like this, right? What happens here? It will terminate this part and gives only 3. So what is value of x is not 3 getting here. 3 getting. Is getting 3 here. Now getting 3. So 3.0. So output is now 3.0. Now. So how do you get the correct value here? Exact value here. So here both operands are integers. In division operation, both are integers, result is integer. Suppose at least one operand is float, result is float. At least one operand. Suppose make it 3.0. 3.0. F means float. Right, okay. Yes. So 10 by 3.0 F. So this is what integer by float. Fine. Integer by float. Now getting correct value. So one of the operand must be float. At least one operand must be float, result is float. Okay. Either like this or A convert into float typecasting. Just you can go for typecasting. A convert into float type. Okay. Now run it. 3.33. Okay. So this case already 3 is a hard coded value. 3 is a hard coded, right? If it is hard coded, directly can you select this 3.0F. 3.0F front as like this. Fine. So here in division operation, to get the float value, at least one operand must be float type. We should convert like this. Yes, as a Java developer, you should take care of all these. Okay. Now, same thing. Suppose integer b is equal to 3. Okay. Now in place of 3, now I'm using b. Right? Yes. Now, again integer by integer, result is integer. Now see this, run it. Yes, it's a 3.0 getting. Now, how to get the correct value? Yes, tell me. Yes, can you advise your coach for this? Can I use B.0f?
We can.
Can I use like this? Yes, it's a variable, right? Variable dot. Yes, how it
Yes.
valid. Suppose data means we can say, suppose 3 points, we can say 3.0f, we can, but it's a variable, right? How can you say? So not valid. So then what's a vector?
So can we do typecasting here?
Yeah, typecasting. Go for typecasting. Go for typecasting. Float of B. Float of B, right? Float of B. Just go for typecasting. Okay, 3.3 getting either this one or this one. Anyone. Any of these two things make it float here. Any of these two things make it float. That's it. 3.33 got it. Yet. So this is data types, different scenarios like this. Okay. Yes, same thing in document also expand here. All these things expand here. So this is about data types and typecasting is like this. Okay, right? Yes, sir. Try to remember all these topics here. Okay. Yes, in interviews maybe asking this kind of things here. Okay. Yes. Yes, next about operators. So this topic tomorrow will continue. Tomorrow taking class. No holiday. Even started no holiday because one class cancelled. Tuesday class cancelled. So for that I'm taking tomorrow. Saturday taking class. Tomorrow taking class. Right, okay. Yeah. So thank you. Yes, see you tomorrow.